Okay, welcome to this podcast. So we're dealing with perceptual organization. We've already dealt with form perception, and now we're going to move on to perceptual constancy. Okay, so again, that's one of the modules in Myers. I believe it's 19.3. So we're going to move on to 19.3. Okay, and this is a helpful way to organize what Myers is trying to do in module 19. Okay, so you can ask yourself, do I understand this concept, this concept, this concept, and this concept, right? So right now we'll deal with what's in blue. All right, so perceptual constancy, what actually is this? Okay, there are certain types of constancies we have: color, brightness or lightness, shape, and size. These are all types of perceptual constancies. Well, what does that all mean? Okay, look at this picture. If you're familiar with billiards or playing pool, right, you obviously know that all of these pool balls are the same size and the same shape, right? You already know that. However, this one does appear bigger to us, right? It is actually sending a different image to our retina. So literally, we also know that from our unit on sensation, that images, right, are projected onto the fovea, part of the retina, right? And that the size of that image changes depending on distance. Okay? Now, what's key to perceptual constancy is we are dealing with familiar objects, and it's also a form of top-down processing. Two terms you already know, right? So bottom line is, this is sending a different image in terms of size, right, onto the retina than this is. But yet, I perceive them as the same, right? I actually don't think this ball, this pool ball, is bigger than that one, right? I don't. I'm using top-down processing. So again, take a look at that definition that's right there. Let's go into a little bit more detail here. Shape constancy. So the same thing. The image that is getting sent to the retina when I look at the coffee cup from this angle is this shape. The image that is getting sent to the retina when I am looking at the coffee cup from this angle is that. However, none of us would say coffee cups are elliptical. We think of them as circular. That's shape constancy. The other thing going on here is we don't think, like if this one were red, right, let's just say they're the same cup, we wouldn't all of a sudden think this is a very different cup or mug than this one, right? We think of it as the same object, right? It's the same object, even though the shape that is sent to our retina is different, okay? We recognize it as the same. It's constancy, right? So again, it has to do with the image that is sent to the retina, okay, which is different, but yet we interpret the object as the same. Brightness constancy, same thing, but now instead of just dealing with color, we're dealing with the level of brightness, okay? So that's the same definition, but the same concept. Size constancy. Now, we know the shape of and size of cars for the most part. And yes, there are some cars bigger than others, but for the most part, we understand how large cars are in general, right? We also know that if we're over here, our little handy-dandy stick figure, right? We also know as the car comes closer to us, so we're talking about distance, the image on our retina, right, will be larger. We do not think that the car is growing in shape if it's coming closer to us, because further away, right, it was a smaller image on our retina, right? We don't think the car is actually changing shape. No. So it doesn't matter about the shape and the changes going on in the retina. Once we have familiarity with an object, a familiar object, we recognize the size as staying the same, regardless of what's happening in our retina. Okay? So regardless of what's happening in our retina, we understand that the car has remained the same size. Okay? So where are our main points? Here are our main points. Okay, so those are for you to read. Now, the other thing I'd like you to do is you can take a look at some other pictures here. And there's also a website for you to click on. Okay? All right.